Okay, so welcome to this video on simultaneous equations, where we'll be focusing on linear simultaneous equations. Again, the topic of simultaneous equations is very important in A-level mathematics, and the theme of solving with methods of simultaneous equations will come throughout the A-level course. Okay, so what is the purpose of simultaneous equations? Well, simultaneous means one after the other, and in this particular page in your workbook we're going to focus on linear simultaneous equations. The geographical context of using simultaneous equations is basically to find points of intersection. When you do simultaneous equations between linear equations, you can get a coordinate, and that coordinate solves both of them. Okay, so if you get that coordinate and put it into this equation, it will make it not only that one minus 15, it will make that one minus 26. In a graphical meaning, that would mean that coordinate is where these two lines intersect. Okay, and there are two methods for solving linear simultaneous equations. There's elimination, which can be used if both equations are linear, and you probably would have seen that quite a lot at GCSE. And there's substitution, which involves substituting one equation to another equation, and that can be used for linear or non-linear. Okay, so what we're going to look at is the questions on this sheet, which regard the simultaneous equations and the linear form. So solve the simultaneous equations 2x plus 3y equals minus 15 and 3x plus 5y equals minus 26 by elimination. So first of all, if you remember from GCSE, you write the equations down one on top of the other. Okay, so once you've written those equations one on top of the other, you've then got to either use elimination or substitution. Now, elimination basically means you'll have to eliminate one of the variables x or y, and you do that by multiplying both of these equations by a number such that you can eliminate one of those variables. Now, it's up to us which one we can do. I can either eliminate x or eliminate y. I'm going to eliminate x. And to do that, I want to make sure the coefficient in front of the x is the same. Okay, and you'll see why. So I'm going to multiply the first equation by 3, so I've just given it a label of 1, the first equation. I'm going to multiply that by 3, and multiply the second equation by 2. Okay, and when I do that, I'll get 6x plus 9y equals minus 45. Okay, and if I multiply this by 2, I'll get 6x plus 10y equals minus 52. Okay, I'm going to call this equation 3 and equation 4. Now, once I've multiplied by these values and I've got these new equations, what I can then do is think about, okay, how can I eliminate the x variable? And I can do that by subtracting one equation from the other. So I'm going to do equation 3 minus equation 4, and when I do that, the 6 minus 6 goes away. 9 minus 10 is minus 1y, and minus 45 minus 52, which means it's a plus 52, will give us 7. Okay, therefore y is equal to minus 7. Okay, so if minus 1y is equal to 7, y is equal to 7. But you also need to get x. Okay, so to get x, you have to think, how am I going to get that? You can put in y equals minus 7 into either of these equations and solve to get x. So let's do that. I'm going to put y equals minus 7 into this one here. So 2x plus 3 times minus 7 equals minus 15. Okay, that will give you 2x minus 21 equals minus 15. And when you do that, you get 2x. I don't want the minus 21 there, I'm going to take it onto the other side. So I get 21 minus 15, which is 6, and divide by 2, so I get x equals 3. Okay, Okay, so the final answer, the coordinate which satisfies both of these equations, is x equals 3 and y equals -7. Okay, so I've solved it. Right, so question 1, that was with elimination. It's a method which you should have seen before at GCSE. Now in question 2 we're going to use substitution. Okay, and substitution will rely on us just being a bit more flexible with our mathematical skills. So x minus y. I'm still going to write one on top of the other. Okay, I'm still going to label this one equation 1 and this one equation 2. Okay, so when we use substitution, we've got to think which equation can we rewrite, make something the subject of, and rearrange into the other equation. Okay, now what we'd like to do is we'd like to rearrange something and make sure it's quite easy to rearrange it. We don't want to rearrange it into something more complicated for us to substitute. So if I'm looking, there's 2 or 3 ways I could do this. Either I can make y the subject here, x the subject there, or y the subject here. In all 3 cases I'll get the correct answer, okay, if I work through properly. So what I'm going to do, I'm going to make y the subject from equation 1. Okay, so from equation 1 I'm going to make y the subject, so it's y equals 7 minus 2x. Now once I've got that, I can substitute that in to the next equation wherever I see a y. So this 7 minus 2x can replace any y in here, and the benefit of that is as follows. When you substitute, so I'm going to label this 3, I'm going to say sub 3 into 2. When you substitute this equation 7 minus 2x in for y, the benefit is that you get a line of just x and numbers, and that's really good for us because we like to solve with just a few numbers and 1 letter. We don't want to have 2 letters and numbers. Okay, so but obviously you've got to be careful with the substitution. I'm substituting 7 minus 2x and it's minus y, so I'm putting brackets around, and when I put brackets around, the minus is on the outside, it affects like this. Okay, I get 3x equals 15. Okay, and therefore x is equal to 5. Right, but I don't only want x, I want y as well. So I'm going to sub into equation 2. I'll put x equals 5 into equation 2. So 5 minus y equals 8. And with a bit of work, you'll get that y is equal to minus 3. Okay, so x equals 5, y equals minus 3. Okay, so that's substitution. Right, question 3. So we now asked to find the coordinates of intersections between 2 lines. And remember what I told you, simultaneous equations, or the method of simultaneous equations by the elimination or substitution, can help us get that coordinate. Okay, so again I've got 4x plus 5y equals 8 and 8x plus 3y equals 2. Now if I look at these 2 equations, it's not as easy just to rearrange and substitute into there, because if I rearrange to make y the subject here, or rearrange to make x the subject here, I'm going to get some weird looking fractions, and it's going to make life a bit more difficult. So I'm going to use elimination here. So 4x plus 5y equals 8, and 8x plus 3y equals 2. Right, and I'm going to analyse which equation would I like to make the variables, which variable would I like to eliminate. And if I'm looking at this carefully, I've got 4x and 8x. I think if I multiply this one by 2, the first equation, then that will make life a bit easier for me. So I'm going to multiply the first equation by 2. 8x plus 10y equals 16. 8x plus 3y equals 2. I'm going to leave that as it is. I'm going to subtract one from the other, I'm going to get 7y equals 14. That means y equals to 2. Okay, and once I've got y equals to 2, I can substitute it into any of these equations here. So 4x plus 5 times 2, which is 10, equals 8. 4x equals 8 minus 10, which is minus 2. Therefore, x is equal to minus a half. Okay, so the coordinate of P is minus a half and 2. That's the coordinate of P. Right, the last question on the sheet for linear simultaneous equations, we got line x minus 5, y equals 8, and we've got another line 2x plus 3y equals 3. Now again, if I look at this, I could multiply this top equation by 2 and eliminate. I'm going to do substitution this time because I feel like I can rearrange to make x a subject here. I'm going to have 8 plus 5y, and again they're asking for the coordinate of the point of intersection between these two lines. Okay, so I'm going to, this is equation 3, I'm going to sub 3 into 2. Okay, so x equals 8 plus 5y. I'm going to substitute 8 plus 5y wherever I see x. Okay, y equals minus 1. I'm going to substitute that in to the x to make sure I get my x value, and when I do that I'll get x equals 3. Therefore the coordinate of intersection is 3 minus 1. Okay, so that is a quick refresher on linear simultaneous equations through elimination or substitution. Okay, and the practice questions are outlined here for you to have a go at. That's the end of the video.